let it be equal to L, and let it be at a distance L. So current, let it be I1. Here current, let it be I2. What about the, just I'm asking, what possible direction in the loop, if it is set free to move, it will move. Or just force along x-axis, 0, non-zero. So two cases, let me take it. There's the one thing. If you want exact, I think you should go by the mathematics. Just now I discussed, no? If they give all dimensions, everything, yes, we can work out here. Just only like force along x-axis, y-axis will be 0 or non-zero. The discussion will be only that much. So let this be the current I2. What about force? I'm just asking you 0 or non-zero. Don't write anything here. Wire AB in what actually explains force? The wire AB. Here you see B bar into the plane current. So it will experience a force here in this direction. And what about wire, the side AC? Current will flow in this direction. No? So put that one. So B bar current, so it will be in this direction. So roughly I'm just showing the directions, the force acting on the wire. So it will be somewhere here, FAB. Somewhere here, so somewhere here should be FAC. Is that okay? Point of application should not be the midpoint, because the field here will be more than this one. So at several points, the force will be acting, but the magnitude of force or pen will be more at this particular point. If you look at the wire AB, how the forces on the wire AB will be like this. If you take this wire AB, the magnitude of force here will be more. It keeps on decreases. It will not become 0. It will become some smaller value. Then similarly on the wire AC, the magnitude of force will be here. They may ask you just these directions also, instead of asking some values. What about on on the wire BC? Next on the wire BC, it will be, so this is A, C, B. Current is flowing like this. No, there is a reason why the forces are in this direction. No B bar current. So on the wire BC, it will be, it should show, I should show the force more here. So it will be so this is what happens. These are the forces that are acting on the loop ABC. Now with the help of this, you have to analyze. With the help of this diagram, you are supposed to analyze here. No? Now, can you say anything about magnitude of FAB? FAB, somewhere the resultant FAB should be greater than FAC. And FCB and FBC, also like FCB will be acting here. Shall we put one thing? FAB is greater than FAC. That much I can say here. So the net the net force along x-axis will be towards left, no? So Fx non-zero. What about Fi? Will be non-zero. Sir, in what specific direction I'm able to say clearly along, because FAB will be greater than FAC and the net force will be towards left. The loop, what happened, will tend to move towards left, set free. Along y-axis, I should work out. I can't say. I should work out with the calculations. No way we can make a guess here. So how to calculate? Calculate the total force FAB, then take component of FAB and FAC along y-axis. Compare with that FCB. the resultant will tell you in what direction it will be. So altogether along x-axis I can say towards left. This will be towards left. About y-axis I'm not sure, we have to take the calculations. You know, similarly come for this. The resultant of this should be b bar. So the force of the resultant force will act somewhere here. Here should be the resultant of force. Only I'm showing the resultant force. What about here? Here I should show the midpoint. Is it clear now? Anything can we say about the forces here? Shall I put Fy 0? Will I agree? Provided it's an equilateral triangle again. The net force along y-axis must be 0. Along x-axis, non-zero, and I'm again we have to depend on the calculations. Fine. So these are some numericals will be there. So I think better once you do calculation, what like previous problem, what I shown method, no, like this, if the equilateral triangle, this angle will be 60 degrees if you take it. Then work out one problem so that you'll be in some comfortable position to answer any questions. Okay, let me